Salam Doctor. We are from Group 12 and our company's name is Invokers and Dian Berhad. Our task is to produce 500 ton, 50,000 ton per year of ethylene by using the naphtha. My name is Liang and my metric number is 198369. And my other two group members will introduce themselves afterwards. So this is our company's body flow diagram. So basically we are going to produce 50,000 ton per year of ethylene through the C2 splitter, which is the last unit. The end product will be at the distillate of the C2 splitter. So firstly, the naphtha will enter into the deputanizer to separate the butane with the other components of the naphtha. After that, it will enter the heater to heat up the temperature in order to enter the furnace. The heater 2 is to heat up the carbon dioxide in order for the higher temperature carbon dioxide to enter the furnace. After that, the flue gas will enter the quench. After that, it will be compressed in the adiabatic compressor. After that, it will be separate. The components, the flue gas, will be separated in the amine absorber to separate the toxic substance, which includes the methane or the carbon monoxide. After that, it will be condensed in the condenser. After that, the pressure will be reduced. The pressure will be controlled in the relief valve. After that, it will enter the debutanizer. After that, the ethanizer. After that, the C2 splitter. And then the end product will be collected just like what I said in the display of the C2 splitter. So to avoid the wastage of the raw materials, we propose a way which is the recycle stream. So the recycle stream, the raw material that we need to create more ethylene is butane, because the butane consists of a reaction in the furnace. That's why we want to recycle back the butane from the ethanizer, which we actually want to eliminate the butane from here. So we directly channel the butane stream to the deprobanizer. After that, the stream will go through a process called purging system. The purging system is to control the stream so that the stream will not be overflow in the furnace afterwards, causing explosion. So after that, you will enter the heater 3. The heater will heat up in order to enter the furnace again. Yeah, that is basically our body flow diagram. So the project design unit. First is deputanizer. A deputanizer is a type of fractional distillation column used to separate butane from other naphtha components during the refining process. The separation is needed to optimize the substance that enter the furnace. So basically, after the deputanizer, we need to increase the temperature by using a heater. So as you can see here, the streams enter the naphtha components include butane, pentane, and hexane. What we need is just butane. What we need is butane. So by using the distillation column method that we learned in the unit operation subject, we are using light key and heavy key method to calculate for this. So in this case, we need the butane as our major feed for the furnace. So the pentane will become the light key. Therefore, it will appear less in the distillate, more in the bottom part of the distillation column. The distillate will consist of a bit of the pentane and the butane, and other components which will be eliminated out. After that is the heater 1 and heater 2, which this is connected from the deputanizer, and the heater 2 is connected to the deprobanizer. Heater is to increase the temperature from the stream in order to into the desired temperature needed for the furnace to work efficiently. All right. So the molar fraction of these components are not changed in heater 1 and heater 2, but the temperature will change from the particulate temperature of the outlet stream of the distillation column to 616, which will be the new temperature to enter the furnace. The new temperature 616 to enter the furnace. Okay. Okay, next is furnace. So furnace is a basic reactor. It's a basic reactor for all the reactions to occur in here. So a furnace is the device used for high temperature heating. High temperature in the furnace is needed for the cracking process to occur. Cracking process is a process in which the heavy hydrocarbon molecules are broken into lighter molecules. In this case, butane will be a breakdown into ethylene. So furnace, as I said just now, heater 2 is the carbon dioxide gas. Is the carbon dioxide entering the furnace. The heater 3 will be connected from the depropanizer. The heater 1 will be connected from the debutanizer. So heater 2 will supply the CO2. Heater 1 will supply the butane and pentane. Heater 3 will supply the recycled stream of butane, unreacted butane and pentane. Basically, pentane will be the inert substance here because pentane will not react in the reaction in the furnace. So after all the reactions have occurred, we'll get these components at the outlet. The outlet temperature will increase to 865 degrees Celsius due to the high temperature, due to the exothermic reactions occur in the furnace. So basically, these are the reactions occur, but in which all are the butanes which occur in the reaction. The butane will have the percentage conversion of 80% in order to convert to ethylene. So yeah, 80% selectivity and percentage conversion to produce ethylene. So yeah, that's basically like that. So for the quench part, quench is to cool down the temperature of the outlet stream of the furnace so that when it enters the condenser, the compressor later, the temperature which is high is not suitable for the compressor. So we need to lower down the temperature in order for the stream to enter the compressor. Quench in this case is very useful because quench is a device which the rapid cooling of the workpiece in water, oil, or air occurs to obtain certain material properties. In our case, we use water to cool down the temperature of the workpiece. So the temperature will reduce from 865 to 180 degrees Celsius, in which the pressure does not change. We use water to interchange the heat transfer of the system. The basic molar composition of all the components in the inlet and the outlet of the quench does not change at all.
Hi guys, and Assalamualaikum warahmatullahi wabarakatuh. I speak to Dr. Hamdan. My name is EMILIA and we are starting to PERDAUS and the metric number is 198458. Now we proceed with isothermal compressor. A compressor is a mechanical device that increases the pressure of the gas by reducing its volume. The pressure is increased so that the next unit, which is the carbon dioxide removal, will have a high efficiency to remove the carbon dioxide gas. The carbon dioxide removal is we use the amine absorber. So these are the units. And for stream 9, the temperature is 100 degrees C and the pressure is 5.8 bar. And we increase the pressure into 65 bar, but the temperature is slightly decreased. The reason is because we using a multi-stage compressor. When using a multi-stage compressor, each of the stage have its own cooler, so the temperature will not be increased to the higher because the cooler cools the temperature in the isothermal compressor. We using 3 stages of the multi-stage compressor. There will be no change in the substance, and the product still will go to the amine absorber. So the amine absorber is a device which removes carbon dioxide from its input. The carbon dioxide must be removed because it will corrode the system of the distillation column. So this is our amine absorber. From the compressor, the temperature is 100 degrees C and 65 bar, and there will be a 2 stream of product. So the first product is all of the carbon dioxide that we want to remove, and the second product is the balance of the substance when we remove the carbon dioxide. The amines absorbers have a 99% efficiency. So we assume the amine will be absorb all of the carbon dioxide and will be released in the stream, and there will be no carbon dioxide in the product in the stream itself. We're using the MEA, which is the amine, as our absorbent to absorb all the carbon dioxide. And these are the properties when it absorbs, and these are the properties when it releases the carbon dioxide in stream 11. So the stream 12 will connect to the condenser. Condenser has the same function as the quench, which lower the temperature of the workpiece, but there are physical properties changes in the condenser. So the temperature and pressure from stream 12 is 100 degrees C and 65 bar, and it will change into a negative 1.19 degrees C, and the pressure will remain the same. And it changes the properties, the physical properties of the substance, which is from gas to the liquid. And there will be no change in the substance. So we proceed with the relief valve. The relief valve is designed to open and release excess pressure from the vessel or equipment, and then to reclose and prevent the further release of the fluid, gas, or steam once normal condition has been restored. It helps in reducing the pressure before entering the distillation column. So this is our relief valve to reduce the pressure from 65 to 5.8 bar, and the temperature also will decrease as it follows the gas law, which is when the pressure is decreased, the temperature also decreases. There is no reaction in this unit also, and the substance also have the same amount in the inlet and the outlet. So we proceed with the next unit, which is the demechanizer.
Assalamualaikum and good day, Doctor. My name is HANIS SUFFIA binti ROSSMAN. Matric number is 197554. And for the next unit is demethanizer. So the methanizer is used in our is a device to separates the undesired methane from the desired stream. So in our plant, methane, which is the light key, is removed 99 with 99% purity, but we only get 0.69 0.96 of methane and in the overhead stream. And some of the ethylene also be removed at the overhead stream because it has a low boiling point. And for the heavy key is the ethylene. So ethylene here will 1% of ethylene will be removed at the bottom stream. And here we methane will be eliminated because we couldn't sell the methane because the purity is not our desired purity. And then the bottom stream will go to the deethanizer. Okay, deethanizer is a device which separates C2 compound, which in our plant is ethylene and ethane, from the C3, C4, and C5 components. And 99% of the light key, which is the ethylene, will be removed at the overhead stream, and 1% of the ethane, which is the heavy key, will be removed at the bottom stream. And the overhead stream will go to the C2 splitter, and the bottom stream will be sent to the propanizer. So the pressure remains the same throughout the deethanizer. Okay, and then next is the propanizer. So the propanizer is a column is one of the distillation column that is used to separate citric products from other components, just like depropanizer, just like the debutanizer, demetanizer, and so on. In the depropanizer, 99% of the light key, which is C2H6, is removed, is sent to the storage tank. 99% of our light key, which is propylene, will be stored in storage tank. Here we got 0.95 of propylene, so we will sell propylene. 1% of the heavy key, which is the butane, is removed here. And the bottom, this is the overhead stream, and the bottom stream will go to the purging. So the purging will is used to prevent build-up in the furnace. The next unit is heater 3, and the heater 3 has the same function as in heater 1 and heater 2. In heater 3, it the inlet stream comes from purging, which contain butane and pentane, and the outlet stream will go to the be recycled back into the furnace, which contains high more fraction of butane, since butane is the main component to produce ethylene. And the last unit in our plan is C2 splitter. The C2 splitter is a last distillation column which separates ethylene and ethane mixture. The product of this unit is ethylene with 99% purity. So in ethylene, the overhead stream contains 99% of light key, which is ethylene. So we get 0.99 purity. It will be stored in storage tank. And 1% of the heavy key, which is ethane. And this ethane, 0.99 of this ethane will also be sold since it has high purity.
So now we will proceed to the next slide, which is the recycle stream. So basically, our recycle stream will start at the detonizer, and then after that, it will enter the depropanizer. After that, it will enter the purging system. The purging system will separate 50% of the desired product to enter the heater 3. After that, the desired product will enter. Will connect with the outer stream of the heater 1 to become one stream to enter the furnace for the reactions to occur. So for the mixing point between this outer stream of the heater 1 and heater 3, there is something we need to calculate for that, as if we calculate as we link the value of the heater 3 directly into the furnace, the Excel cannot be calculated directly, as it will as the self-referencing error will occur because we didn't use a solver tool. So in order to solve this problem, we need to use a solver tool, which is this one, the solver tool. So before we do for the solver tool, we need to have a table. So the first column of this table is the original flow rate. The original flow rate is from the heater 1, and the recycles from the heater 3 is from the stream from the heater 3, the outer stream of the heater 3. So the final run is the addition of these two columns. This original flow rate and the recycle of heater 3 is the addition of these two columns. So basically, this solver system is to iterate the assumption run, which will be assume a number afterwards to get closer to this value in order to achieve zero. Which means the assumption run and the final run at the end of the day will get zero in difference, will be the same value among each other. So in order to calculate the difference as zero, we'll calculate the difference first for this one. For more accuracy, for more accurate, we calculate for the square of the sum of the we calculate for the square of the sum of the difference here. So we input this value, we input this this particular box into the set objective of the solve parameters here. After that, we set the value as 0 because we need to iterate all the values into 0. After that, by changing the variable cells of the assumption run, so we link the value of the assumption columns here. After that, we press solve. Boom. Then it will appear this this particular box, which will ask us to whether we want to keep the solution or not. So we if we press OK, all the system will change to constant mass flow rate of the total system, total mass flow rate of the system, which means that because if we keep on recycling, the value will keep on increasing. So until the increasing factor increase until amount where the increase in the mass rate is not that significant anymore, that is the value that the solver wants us to get. So the values that we get is very constant, which you get a difference in 0 for many trials of loops. So as you can see at the end results of the assumption run and the final run, we get the difference as 0, and the sum of the square of the difference is also 0. So which means we have gotten the results correctly. So based on here, you can see that we have linked the assumption run to the table in the finance, so that this assumption run that we have calculated through the box by using the solver tool can be inputted can be linked into the table of the finance, so that the whole systems will run according to that value, and therefore it will become constant value eventually.
Now we'll continue on the analysis part. Okay, so we have 3 feedstock, including the utility. So for our feedstock, we have naphtha, which is our main raw material, carbon dioxide and water. So the amount of naphtha we get is quite high, which is around 395,290.31 ton per year. This is for the water, carbon dioxide, and electricity. For the maximum price of our raw material is 760 USD, and the minimum price is 390 USD. The price of our electricity is 0.13 USD per kilowatt. So the total cost of our feedstock is the maximum cost is this, minimum cost is this, and the average cost is around 255,486 277.94 USD. So this is the naphtha price forecast. So the forecast is from 2050 to 2025. So from this forecast, we can see that the lowest price of naphtha is in 2060, which is 390, and the highest price is 2060 USD. So for the total cost of for the product, we sell three products. The main product is ethylene, the other byproducts is propylene and ethane. So the amount of ethylene produced is 50,000 ton per year. And this in propylene, and this is ethane. So the maximum price of ethylene that we find is 1,600 USD, and the minimum price is 390. Well, this is the maximum and minimum price of propylene and ethane. So the total product that we could, the total profit that we could gain by selling this product is the maximum is in this amount, minimum is this, and the average cost is around 87 million USD. So for the capital cost, The total capital cost is 1,400,000. The capital cost include the transportation, freight, engineering, construction, equipment cost, and so on. So for the total operating cost, which is include the labor plus plant overhead plus lab capital charges, variable costs. The total operating cost that we get is the minimum is around 255 million USD per year. So this is for the ethylene demand. We find the ethylene demand from 2070 to 2037. The ethylene demand is keeps increasing from year to year. So because we only need to produce 50,000 ethylene ton per year, so this couldn't be a problem for our plant. So the ethylene price history is we find from this ethylene price history. So the lowest price is in 2009, which is 390 USD, and the highest price is in 2060, which is 1,600 USD. So this is our company's cash flow. As you can see, our company experience losses, and our losses keeps increasing from year to year. So the maximum minimum profit that our company got is the maximum profit that we could get is a negative 67 million USD, and the minimum profit is negative 290 million USD something. Thank you.
Now we'll proceed with the step for competing with other companies. The first one is select important geographic location. Geographic location is very important because when our location is very easy to access, there will be more customers that want to deal with us. And the second one is the choice of state should be in high political place. This is because high political place have a growth economy. So when we do our business in the high economy state, so we will gain a lot of benefits and profit from it. And the third one is choosing a country should be high currency, and the fourth one is find their strength and weaknesses. When we have a rival, we should find their strength and weaknesses so that we can improve our company to be more competitive in the future. So these are the ethylene price located in Pulau Bukom Island in Singapore, which is the petrochemical corporation of Singapore. These are the price on this date, and these are the price for this. So the risk management procedure. So the first one is process. The process of producing ethylene and selling it without causing any spill is more important than competing with other companies. So we need to improve our company first, and then consider the competitor and set a competing plan to increase the profit. Talking about natural disaster, assessing the business will help to know which aspects will be affected and focus on them. For example, because we have a low profit, so we can reduce the transportation cost. And also search for the state that need high amounts of ethylene, or search the one that has less competitor and sell it. So by the time we can improve and overcome our loss. The second one is the risk identification. Ethylene is an industrial gas produced in controlled high temperature. Since it is highly flammable and explosive, it must be protected from a contact with a direct heat. To overcome this issue with less damage, the factory should not store any extra amount, and if they have it, so we should sell it in a local market. In other words, produce less amount in the critical conditions and speed up the process if the contracts are signed. Okay, the next one is risk responsive planning. To reduce the impact of the risk, look for alternative power source that will be saved in the production process and cost less at the same time. For example, the productivity should be standardized and does not change according to individuals. And also, find partners so that the damage will be shared and the profit as well. Inform the third parties about the disaster and show them how it is manageable to perform under these conditions. In order to compete with Other companies analyze the services and try to give the customer other advantages like late payment, computation for any delay, and lower the cost at the beginning, then gradually increase if after a while. So now we proceed with the market analysis. These are the percentage of invoker in US. As you can see, it's by region. And invokers in Bahrain cannot compete with other companies well because their servicing profits are higher as their contribution in markets are longer than us. When the company is longer, so they have many business and many are widely known. Our sales company have opened for 2 years, have operated for 2 years only. So we need to be in the market much longer, and we should exercise our company much more very increasing in the exercise so that our company will be in the future will be able to compete with them. So in conclusion, by feeding 395,000 tons of naphtha each year, Invokers Nirvaha can produce 60 tons of ethylene per year. So the recommendation, the costs are very high. Our company needs to find other supplier that sell naphtha in a very minimum price, and the waste from the process is not being handled properly. And the recommendation is the filter unit should be added, hence the waste will not affect the environment safely. So that's all from us. Thank you for watching.